Okay, so let's talk about the concept of charge. So charge. Now we're going to quantify charge in a bit. So I'm going to give a symbol to charge, and for whatever reason, the symbol for charge is lowercase letter q. Why? I don't know. Just roll with it. There it is. So we know that charge can be positive, negative, or neutral, but what is this all about? Well, if I were to ask you from your study of chemistry, what do you know is something that is negative? You'd know that would be an electron. So let's look at the electron. Well, not actually look at it, but, right? If I said something that's positive, you would say a proton. If I said neutral, you would hopefully say a neutron. All right. So electron, proton, neutron. Now we know that an electron has a negative charge. A proton has a positive charge. Neutron is neutral. All right. So let's just talk a symbol. So if I want to say one electron, symbolically, I might say 1 E minus. If I wanted to say a proton, I'd say 1 P plus. And a neutron, 1 N 0. Okay? But what else do we know about the electron, proton, and neutron? Well, we know that they're very, 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 very small. In fact, from a mass perspective, the electron is 9.11 times 10 to the negative 27th kilograms. Really, 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 really tiny. The proton is 1.67 times 10 to the negative, this is negative 31st, even smaller. This is the negative 27th kilogram. And the neutron has just about the same mass, right? To that number of significant figures, it is the same, but the mass of a neutron is actually slightly bigger than the mass of the proton, but just like slightly, slightly, slightly bigger. So that's that. Now, here's what hopefully you remember from chemistry. If I were to ask you for a neutral atom, right? So say a neutral atom of carbon. Well, what do we know about carbon? Well, carbon 612, yes? Ah, yes, chemistry. What do I know about that carbon? I know that that carbon has, well, the atomic number is 6. It has 6 protons. And then the mass number here is the number of protons plus the number of neutrons. So this is has 6 neutrons. So then this 6, the atomic number, is the charge of the nucleus. But most, atoms themselves are neutral. So if atoms are neutral, we know that this thing has 6 protons and it also has, therefore, 6 electrons. That must mean that whatever the charge on the proton is the same amount as the charge on the electron if 6 protons plus 6 electrons could yield a neutral charge. So, how much charge do they have? And this is where the work of Charles Coulomb comes in, and we have to put numbers to it. Now, there's 2 ways to express the charge of an electron. We can express the charge of an electron in units that are called coulombs, after charge coulomb. The charge of an electron is negative 1.6 times 10 to the negative 19th coulombs. It's a very small amount. That must mean that the charge on the proton is plus 1.6 times 10 to the negative 19th coulombs. And the charge on the neutron is 0. But that's really awkward for our work, and we don't really care about that. So what we're going to do is make up a new unit of charge that's more convenient. We'll say that the charge on a proton is plus 1e. Now notice here, that's just e, that's e minus. Different things. That's a symbol for an electron. This e is something that's called 1 elementary charge. Okay? So if the charge on a proton is plus 1e, the charge on an electron must be minus 1e. and then the charge on the neutron is 0. And so those are the facts about the electron, proton, and neutron. From a little bit of a historical perspective, the electron is discovered first. It's discovered in 1901 by a man named J.J. Thomson. The proton is discovered a little bit later. We know that the nucleus is discovered first. The nucleus is discovered in 1911 by a man named Rutherford with a very specific shiny experiment you may have learned about in chemistry called the gold foil experiment. Anyway, Rutherford goes back later and in 1915 discovers the proton, and then it's not until 1923 that James Chadwick discovers the neutron. So we knew all this stuff about electrostatics well before knowing about electrons, protons, and neutrons, but now that we know them, we can explain what's going on. So here we go. Let's say I have our balloon. Let's say that our balloon is initially neutral. Well, that neutral object, what does it mean for an object to be neutral? When an object is neutral, that doesn't mean it's composed of neutrons, right? As we showed here, this carbon atom was neutral, but that was because it had not just neutrons, but protons and electrons. But what that just means is equal numbers of electrons and protons. So therefore, what would it mean for an object to become negative? Well, for an object to become negative then, it must have more electrons than protons. And for an object to become positive, therefore, it must have more, or fewer electrons than protons. Probably a better way to say that. Fewer electrons than protons. So, if I have a balloon, well, how many atoms is a balloon made out of? And usually this is when people say millions and billions, but that's not even close to the truth. Hopefully from chemistry you remember the word moles. A mole of something is 6.02 times 10 to the 23rd of something. It's like a dozen, but just a lot larger, right? A balloon will be made out of moles and moles and moles of atoms, right? That means that this balloon probably has, billions upon billions upon billions upon billions of protons and billions upon billions upon billions of electrons and also neutrons as well. We just don't care about them for this. And if that balloon is negative, that would mean that this thing, for every proton there's an electron, right? So when I make something negative, there's two ways to do that. Either I've got to be adding electrons, or I've got to be removing protons. And that means to become positive, I either have to be removing electrons or adding protons. Well, which of those things happen? Hopefully you remember from chemistry that in each of these cases, when an object becomes charged, it's because electrons are moving around. We're never going to be removing protons or adding protons. Why? Well, think about where the proton is. The proton, if I'm going to draw an atom, is on the inside, and the electron is orbiting on the outside. So the proton's on the inside means that that's much harder to move them around. Also, you remember that the type of element that this is based on the number of protons. Right? If I'm removing protons or adding protons, that's like I'm doing magic and changing one substance into another. That's not happening. So every time we charge an object, it's because we're adding electrons or removing electrons. Electrons are going to be the mobile unit of charge that moves around to cause something to become positive or negative. Right? So let's get back to our balloon then. We know that our balloon became negative. So if our balloon becomes negative, what must have happened to it? If you said, when rubbed with the fur, here's my piece of fur, that this thing became negative, right? The fur became positive, this thing became negative. Well, what must have happened? Well, what happens in this interaction is electrons leave the fur and go to the balloon, right? The second that this balloon has more electrons than protons, it is negative. Now, here's the thing, though. I'm going to draw some electrons, some excess electrons here. That's not saying that there's no protons. It's that if there's 1 billion protons on this, there's like 1 billion plus 10 electrons. All that matters is a charged object has an imbalance of charge. So when we talk about what is the charge on the object, really what we're asking is how much is the charge imbalance? You're not asking for how many electrons it has or how many protons it has. You're asking how many excess electrons does it have, or how many missing electrons does it have. So I'm gonna, boom, right? So this thing has an excess of electrons. This thing has a lack of electrons. And that's how we want to describe things that are negative and positive, because it's electrons that are moving around. This process of taking two neutral objects and rub together such that one ends up positive and one ends up negative is something called charging by friction. And that's what we've been doing, is charging objects by friction, making one positive and the other negative. The positive one is giving up excess electrons, and the negative one is accepting excess electrons. So every charging process, right? And that's important. Last thing for this video. Every charging process is about a transfer of electrons. Electrons have to leave one thing and go to another for a charging process to happen. And so we'll talk about some other different types of charging processes in some later work.